Since 2022, AI was the world's most impressive consultant. It could analyze anything, draft anything, explain anything, but it could not do anything. You got the perfect email and still had to send it yourself. The perfect database query and still had to run it yourself. A gap existed between AI knowing and AI doing. In 2026, that gap is closing. This is how it closes. By the end of this, you will understand exactly what an AI agent is, why most of what gets called an agent is not one, and what the real architecture looks like when it is built to work in production. We will go from the problem through the mechanics, through the protocols, all the way to why 40% of these projects are still getting canceled. Let us start with what broke. A chatbot is a vending machine with a very smart button. You push it, it dispenses one response, and the transaction is over. The model waits, you push again, it dispenses again. There is no loop, no memory of the last button push, no ability to go fetch something not already loaded in the machine. That is not a design flaw, that is the design, and it is why agents exist. A real agent is not one thing. It is 4 departments operating in a specific sequence. Conflating those departments is the fastest way to build something that looks like an agent in a demo and falls apart in production. Each layer has a distinct job. Get any one of them wrong, and it does not matter how powerful the model at the center is. The system fails. Layer 1 is perception. Think of it as the airport security checkpoint. Everything entering the system goes through screening before it reaches the decision maker. Emails, API calls, user messages, database reads. All of it is validated, sanitized, and formatted into a structure the agent can reason over. Skip this layer and malicious inputs reach the reasoning engine. That is not a performance problem. That is a security failure. Layer 2 is the reasoning engine. This is where the model lives. Think of a chess grandmaster who plans every move but never physically touches the pieces. The engine interprets the goal, decomposes it into steps, selects which tool to call, and evaluates whether it succeeded. The most common reasoning pattern is react. The agent writes out its thinking before taking any action, making every decision traceable and debuggable. Layer 3 is memory. Without it, every session starts from zero. The agent has no knowledge of what it tried last week, what query failed this morning, or what the user told it 3 messages ago. With memory, the agent builds on prior attempts and avoids repeating known failures. This is the layer that separates a tool you use once from a system that actually gets better over time. There are 3 types of memory. Episodic memory holds specific past events, tool call results, and session logs. Semantic memory holds factual domain knowledge, retrieved from vector databases when needed. Procedural memory holds the knowledge of how to do things, encoded in system prompts and tool descriptions. A production agent uses all 3 simultaneously and needs a state store so work can resume exactly where it left off after an interruption. Layer 4 is tool integration. This is the only layer that actually does anything in the real world. APIs, databases, file systems, web browsers, code sandboxes. Each tool is described to the agent with a name, a description, and a schema defining what inputs it expects. The agent selects the right tool and parameters. The system executes it and returns the result. Without tools, the agent is still just generating text. Here is the problem. Even a perfectly built 4-layer agent is an island. Before 2024, connecting AI applications to external tools meant writing custom integration code for every combination. M applications and N tools meant M times N bespoke connectors. Every time you added a new tool or a new application, the cost multiplied. The industry needed a universal port. In November 2024, it got one. Anthropic introduced the Model Context Protocol in November 2024. Before USB-C, every device needed its own charger. Before MCP, every AI application needed custom code for every tool. MCP is the universal port. Implement the server once for your database or API, and any compliant AI application can connect immediately. Late 2025, its SDKs crossed 97 million monthly downloads. In December 2025, it became an industry standard under the Linux Foundation. MCP is vertical. It connects an agent down to its tools. But what about agents talking to other agents? Google introduced the agent-to-agent protocol in April 2025. Think of email between companies. You do not need to know what software your client uses or how their servers work. You only need their address and a shared language. A2A gives agents the same capability across organizational boundaries without exposing internal architecture. Here is a distinction that gets missed. Tools are what an agent can do. Skills are how it does things well. A blender is a tool. The smoothie recipe is a skill. You need both, but the recipe determines whether the result is drinkable. Skills are packaged as instructions and procedural knowledge that tell the agent which tools to use, in what order, and how to handle what comes back. Raw capability is not the same as competence. There is a cost hidden inside MCP that most teams discover too late. One well-designed MCP server, the GitHub integration, can load more than 50,000 tokens just describing its available tools before the agent has reasoned a single step. Skills solve this through progressive disclosure. Only metadata loads at startup. Full instructions load when activated. Resources load only when needed. A workflow that would cost 150,000 tokens compresses to around 2,000. A reasoning engine plus tools plus protocols is still not a system you can ship. You need the control layer. The harness. Think of the flight control system on a modern aircraft. The pilot makes decisions, but the flight control system manages autopilot modes, coordinates instruments, enforces safety limits, and handles failure recovery. Even the most skilled pilot cannot safely operate a modern aircraft without it. The harness is that system for your agent. In practical terms, a harness handles task sequencing, retry logic when tools fail, cost budgets so the agent does not run indefinitely, context compression when the context window fills, and human in the loop checkpoints for decisions that require approval. LangGraph uses graph-based state control. Crew AI assigns roles across multiple agents. Mastra is TypeScript native with observational memory built in. Each approach is different. All of them make production possible. Here is what no harness currently does. None of them validate the quality, lineage, or freshness of the data flowing through the agent. They manage how the agent operates. They do not govern what the agent reads. Schema drift, stale tables, and uncertified data sources are the most common root cause of production agent failure. The framework assumes the inputs are clean. In most real deployments, they are not. Here is where we actually stand in April 2026. 40% of enterprise applications will embed task-specific AI agents by year-end, up from less than 5% 18 months ago. In that same period, trust in fully autonomous agents fell from 43% to 27%. Deployment is accelerating. Confidence is falling. Those two numbers moving in opposite directions are the defining tension of this moment. Gartner estimates that only about 130 of the thousands of vendors claiming to sell AI agents are building genuinely agentic systems. The rest are rebranded chatbots, repackaged automation, or AI assistants with a new marketing layer. Agent washing is not just a branding problem. Organizations that buy the rebrand deploy chatbots expecting agents. When those systems fail to deliver on agent-level promises, the projects get canceled, and the technology takes the blame. Roughly 70% of AI projects fail to reach production. The most common reason is not model capability, it is authorization. The agent can reason perfectly, select the right tools, and form a flawless plan. But if it cannot securely authenticate to your CRM, your database, or your internal APIs, it cannot act. The governance layer is catching up, but slowly. NIST announced an AI Agent Standards Initiative in February 2026. The EU AI Act is beginning to reach agent-class systems. But agents are scaling faster than the frameworks designed to govern them. The organizations surviving this period built internal governance before regulators required it. Governance lag is not a future risk. For most teams deploying now, it is a present one. For the organizations that get the architecture right, the returns are real. The average return on investment for enterprise agent deployments sits at 171%, with US-based companies reporting 192%. By 2028, Gartner forecasts that at least 15% of day-to-day work decisions will be made autonomously through agentic AI, up from 0% in 2024. The architecture works. The failure rate reflects implementation quality, not fundamental limits. The gap between AI knowing and AI doing is closed. A loop, 4 layers, a universal tool protocol, an agent-to-agent communication standard, a harness that keeps it running, and a governance layer that keeps it accountable. That is the anatomy of a real agent. The question is no longer whether you can build one. The question is whether what you are looking at is actually one, or just a very well-dressed chatbot.